if you'll double click on that case MFDB right there, that will launch the AXIOM examination or the case file, and we'll be able to see what. Now this is only RAM. That's it. We're not looking at hard drive. We're not looking at thumb drives. We're not looking at phones. What you're going to see in all of the artifacts found and recovered from this is going to be recovered from RAM. Okay? And I'm going to continue to say that over and over again, because the more you see that we're able to recover, and this isn't one I staged. I literally, you'll see, I did it between 10 o'clock at night and 2:30 in the morning because I needed to get it done. So it was one of those things where let me just put it all together, and then I'll gather it, and I'll do an investigation on it, and then I'll do the class based upon that. It turned out really good, but I've done other RAM investigations that turn out just as good. You never know what's going to be in RAM. So, all right, let's go back to PowerPoint. You guys can stay on yours. Let's walk through this. I always like to start with the funny and end with the funny. So here's my start with the funny. I don't need to check anything with the boys in forensics. I know it was you. And she's holding obviously a missing cupcake up there, right? So let's talk about RAM real quick. What is RAM? RAM is volatile. Data on the hard drive is not. Unless you kick it across the room, then it's pretty volatile. But other than that, if you take care of it, if the hard drive loses power, it doesn't lose its data. RAM loses power, RAM loses data. Okay? So let's keep going with this. Was anybody around for this era? I'll out myself. I was around for this era. All right, so yeah. My very first computer was a 28610, 286 with 10 megahertz with no hard drive. It was a 5 1/4 floppy MS-DOS 3.1 operating system. That was my first computer, 1988. And these SIM chips were how you upgraded your memory. You'd actually have a SIM puller. You would pull the SIM chip out of your motherboard and you'd put another one in, right? And these SIM chips, I think, were 8 megabytes each, and I had a total of 32 megabytes of RAM on that machine. So why do I show you this? Because you're like, that's so 1988. Why are you talking about it now, 2019, some 21 years later? Because things are different now, and that's what I'm trying to bring across more than anything else. Things are different now. Would you walk past the 32 gigabyte thumb drive laying on the desk at somewhere where you were collecting the hard drive for a computer or an incident that you're interested in? Of course you wouldn't walk past that. Are you walking past 32 gigs of RAM when you shut the machine off without collecting the RAM?
Yes.
Yes. I'm going to make you make a choice. After this class, if you're not realizing the capabilities, I'm going to force you to make a choice after this class. You're going to have to say, I'm knowingly throwing away evidence. Okay? And I'm doing that on purpose. So if you don't want to have to make that choice, so the next time you stand up in court, I would say get out now. Because I'm going to force you to make that choice. All right. What the key to this slide is that there's a north bridge chip and a south bridge chip. One uses one uses the other. And the key that the hard drive, the CPU, can't feed directly to the hard drive. The CPU is what processes everything and puts everything in order that we can understand it as humans, right? And if I have data on the hard drive or data coming in through the NIC card from the internet, it has to get to the processor. The processor doesn't have a way to talk to either one of those items. But that's where the data resides. So how does it do that? It gets thrown into RAM first. RAM is what the CPU can talk to directly. So what can be in RAM? If everything coming across the internet, everything coming from the hard drive has to go to RAM first, what can be in RAM? Anything and everything, exactly right. So leaving behind RAM is saying, let me ask you a question. I'm a defense counsel now, you're sitting on the stand, and I say this. Is it possible, it's a trick question already. Is it possible that there was exonerating information in RAM that could have proven my client innocent? What do you have to say if you didn't investigate it? Yes. You have to say yes. All right? That's the choice I'm going to cause you to make. Okay? Because you have the tools to investigate it. If you have AXIOM, it's free if you have volatility. Right? So if you have volatility is free. If you have AXIOM, it's a lot easier, and I'll show you why in a few minutes. So, memory is categorized into pageable and non-pageable memory. Who determines whether or not memory from a program can be put into the page file or not? When we talk about a page file, we talk about the page file.sys for Windows, right? It's the swap file. The person who designs that program can decide whether or not that part of the program gets put into RAM or not. It can be important. Here's how page works. We'll talk about the page file. It says page file is usually, or a page in memory, is usually 4096. I wanted to put always. I hate always, I hate never with forensics, because always and never are pretty finite, and things change. So you might have this PowerPoint a year from now, and pages of memory might go to 8192, right? But right now, pages of memory, and they have been for years, are 4096. Who's ever in here has received a blue screen? Yeah, and it says page fault, memory error, blah, blah, blah. Let's talk about that. Pages in memory are 4096. A page in memory is akin to a sector on a hard drive. How big is a sector on a hard drive? 512, without a doubt. So a sector on a hard drive is 512. That may be changing soon to 4096, but it's not right now. When I say sector on a hard drive, I think 512. When you see here page in memory, you think 4096. Good to go? All right. Windows uses that page file.sys. Let's say I have Windows open and PowerPoint open, and of course, my operating system is open as well, right? Let's say I want to open up another program, and that program happens to be calc. Simple calculator, calc.exe. But I'm using all 8 gigs of my memory, okay? I'm maxed out on my 8 gigs of memory. So what has to happen before I can open up calc? I have to dump some of that memory for that active program of Word or PowerPoint. So let's think about this. Which one's active on the screen now? PowerPoint, right? So which one is it going to page? Is it going to page the operating system or Word? It's going to page Word. So it puts Word, whatever can be paged from Word, it puts it into the page file, clearing up enough room for calc.exe to run. Then calc.exe runs. Okay? Now what happens if I want to use Word again and I click on Word? Before it comes up in the focus and I see it and I can use it, it has to reload the stuff from the page file into memory before I can use it. Because remember, the chip, the CPU, can't touch the hard drive. That's where the page file.sys is the hard drive. So it's got to load back into memory, which means it has to offload something else, which is why the page file is usually the same size or twice as big as your current existing memory. Okay? So, having said all that, we just talked about this. Okay, virtual memory. Each process is given 2 gigabytes of virtual memory from the get-go. So if you start a process like calculator and it's only 100 kilobytes of memory, it gets a virtual memory space of 200 gigs. Sorry, 2 gigs. 2 gigs. And that becomes important when you're trying to collect memory across a network. It's going to show each piece of memory that you're looking at, each memory process being 2 gigs large, even though it's really not 2 gigs large. It's going to show that because that's the virtual memory size. So don't worry about that when you're looking at it. All right, next. Without virtualization and doing a memory, let's talk about how it works. And you ever try to recover pictures from RAM? Like you get a RAM image and you carve it for pictures, and what do you get? What do you get?
I have a picture.
Yeah, you get the rest of it's all grayed out, right? Yeah. Or a quarter of a picture, depending on how big the picture is. Yeah, I get some. So the reason why that is because memory is almost never contiguous. It is almost always fragmented over the memory space. So I expect to have one, let's say it takes up 5 pages of memory to store this picture. 1, 2, 3, 4, 5. It doesn't have a way to put it back together when we're looking at the entire memory space. But if we could put that memory back together prior to collecting it, would that be something we'd want to do? It'd be like defragmenting it prior to collecting it, okay? Keep that in mind, we'll talk about that later. But right now, we expect that memory is going to be scattered throughout RAM. But we always have to take a RAM image as is, block it from beginning to end, and however it is. The memory manager is what controls, like an index to a book, it controls where everything is. So if we can query the memory manager and put those processes back together, imagine this, and then carve them for data, are we going to get more data back? Absolutely. Every time. Okay? So let's think about this. We'll go back. When we're dealing with malware, we always pull the malware out of the memory image in full before we examine it, right? Why is that? Because I don't want to see the malware spread out all over, half the code here, part of the code here, all the code there. No, put it back in order and I see the code in order. Same thing with pictures, all right? So let's think about that when we move on. All right. What sort of things can we find in memory? So these are some of the things we can find in memory. These are everything I can find in memory utilizing volatility. Not everything. Some of the things I can find in there using volatility. Open registry keys, open network sockets, decrypted versions of otherwise encrypted data, contents of Windows keystrokes. What do I mean by decrypted versions of otherwise encrypted data?
It's got to be unencrypted for
Like what? I got a good example. Let's use TrueCrypt. TrueCrypt on the hard drive is a file-based encryption, right? So it has a TrueCrypt container, and everything in that container is encrypted. I load in TrueCrypt, and it puts the keys into RAM, and as I need something, and as I click on something in that container, before I can use it, it has to pull it out, put it into RAM, and decrypt it, right? Then it makes it usable. That way, if we lose power, when we lose power, what's on the hard drive is still secure. It's still encrypted. That makes sense. It's a failsafe. Okay? So, the only place I'm going to find it decrypted is where? In RAM. You want to walk away from that without having the password for that TrueCrypt container, without getting the keys from RAM, or without collecting RAM? You may never get in that container again. We'll keep going. Here's the things you can grab with AXIOM. Some of the things. There's a ton of others you're going to see in a few minutes. Network artifacts, URLs, passwords, decrypted data, caches, clipboard data, encryption keys, event logs, IP addresses, chat, internet history, Google searches, link file. This looks like I'm investigating a hard drive, doesn't it? Yep. What can you find in RAM? Anything and everything. Anything that's on a hard drive, anything that's from the internet, you can find in RAM. So this is really not an accurate chart, is it? Nope. It's just something so I can have a talking point to say that's just a scratching surface, right? Anything I can find on computer memory, on computer hard drive, I can find in memory as well. All right. NIST guidelines. The National Institute for Standards and Technology. The National Institute for Standards and Technology says to gather data, volatile data from a computer is imperative. They use the word imperative. That's pretty strong language. Imperative meaning we have to, right? Okay. That also use the verbiage that we need to be able to use minimal invasiveness. What's being minimally invasive? I'm going to go ahead, it's the only time during any of my talks that I actually talk negative about a competitor or a competitor's product. Who in here uses FTK Imager to gather RAM? Stop. Not because it doesn't gather RAM, it gathers RAM. You've used it, it works well, right? It has the largest footprint in memory, gathering memory. So think about it like this. If you walk into this room, and this room happens to be a scene where something happened, you want to disturb it as least as possible, right? So you don't send in your 12-foot, your Bigfoot in the room, blowing a china shop to mess up stuff, right? That's FTK Imager in memory. It has the largest footprint of all the memory analysis tools. Now look, we're not the smallest. We're the second smallest. Dump it is a memory allocation tool. It beats us by a couple of bytes. But it's the smallest. Now, minimal invasiveness. Who determines what's minimally invasive? Why do they use such bland language in NIST? Because technology changes. And the NIST is a government agency, and they rarely change their regulations every 10 years or 15 years. So they wanted to make sure they used a term that was all-encompassing, that was kind of open to the community to define that. If I have a tool that does the same thing and adds no additional functionality as this tool, and it writes less of a footprint, it is minimally invasive compared to this one. Agreed? All right. I'm telling you, it's a matter of time before we go to court and we find a program like FTK that has such a large footprint. Why am I singling them out? When was the last time somebody saw FTK Imager updated? That's all I'm saying. It's a good tool. It's a good tool. It acquires, it's free. I like all that stuff about it. But free doesn't always mean the best. We have a free memory imager, take ours. Use dump it. Use something else. Do your own tests. Trust but verify. All right? Anyway, let's get past that. If I want to add memory into AXIOM, how do I do it? Acquire it with whatever tool you acquire it with. This is one of the options here. I go to evidence sources. One of the options is memory. I click on memory. When I get done, I have to give it an image profile. I have to tell it what memory image this is coming from. A Windows 10, a Windows 7, a Windows 8, 64-bit, 32-bit, 1709, 1803. What version of Windows is this, right? So all of the above. I kind of have to tell which one. Or, if you look at this right here, there is an option to, I want AXIOM process to provide a list recommended image profiles. We will, I say we don't do it, AXIOM does it through volatility. We port volatility in to do all this stuff. It's a partnership. Volatility will run image info, a volatility module, to determine which one of these profiles it should use. If you run it with that, I want AXIOM to provide a list of recommended image profiles, it could take 3 minutes and it could take an hour. But I just want you to know this, it's not AXIOM. It's volatility. We're just porting into volatility. So if you want to say, well, I'm just going to stop AXIOM and I'm going to do it myself in volatility, you just start it over again. So now you got another hour to wait, right? So where we allow you to put in your own is because you've already gotten the computer, you're back in the lab, and you look at the computer in operating system information says it's Windows 10 64-bit with 1803, then you don't need to run image info. You can just put it in yourself here, right? Because you know that RAM came from that computer. You know what that computer was, you're good to go, all right? But what I'm going to tell you is, once you get on with this, these are the modules that we use, that we've ported into volatility. We expect to have more. We update all the time, all right? So what you see in parentheses would be the module inside of volatility. That would be the command you would run inside of volatility to get the information. What you see outside of the parentheses is what we call it. All right. Let's talk about RAM keyword searches. Let's talk about RAM keyword searches in memory. Our memory searches, can we search in ASCII and Unicode? Sure we can. We always will, right? Just like we search on a hard drive. But there's one more thing. I've heard of ROT13. ROT13 is, I wouldn't even call it encryption, I'd call it an obfuscation. Microsoft is famous for using ROT13 to obfuscate stuff. A lot of items in memory is ROT13, I'm not saying encoded, but I'll call obfuscated again. ROT13 obfuscated. Why? I don't know, ask Microsoft, but it is. So if I want to search for a keyword in memory, I'll search for the ASCII version of the keyword, I'll search for it in Unicode, and I'll search for it in ROT13. Now, how do I search for something in ROT13? Anybody speak ROT13? No? Okay. There's a ROT13 online decoder. You just type in ROT13 online decoder, whatever. You type in your keyword, it will spit out what it is in ROT13. Or, if you're a real geek, you can use a chart like this with a chart like that rewrites the alphabet. As you can see, RKR is actually EXE. So if I go up and I say, okay, I want to look for Jamie, J-A-M-E-Y. All I do is the translation. I would add that in as my keyword, and I would search RAM for that. Okay? These are some artifacts that was covered from this RAM. How many artifacts do I see here? 416,858. Only RAM. Now granted, 160,000 of those were keyword snippets, so I did some keyword searching for this across this piece of evidence. But 217,000 came out of volatility. 217,134 artifacts came out of volatility. Guess what the rest came out of? AXIOM. You're going to get the best of both worlds with using AXIOM and volatility together. Who's used volatility in the past? All right? Mr. Zawal, help me out here. When you run volatility across a memory image, what output do you get as a result?
It's been a while.
Anybody? Text, right? You get a text. It spits out text from the screen, right? I can either copy it from the screen, or I can use the greater than, and spit it out to a text file, right? Bottom line is I get this blob of text. And if you start running commands like get SIDS, you're going to get not a blob of text, you're going to get 300 pages of text. And then I have to manually read through them to figure it out. The beauty with putting it in through AXIOM, and you're going to see this in a few minutes, is that our connections works, our keyword searching works, our everything works, because each one of those results that we run, all those volatility commands we run, we put back into our SQL database. We put it back into our SQL database so we can effectively run searches against it, run connections against it for analytics, do all of the things without having to read through a text file. You're going to see in a few minutes how easy that works out to be. All right. Let's go live. So we're going to go live, hop out of the, you guys can follow along if you want. Give me 1 second, play catch up here. All right, so what I want to do is I want to start this out. We talked a little bit about true encrypted RAM, right? So in the top right-hand corner, let's type in TrueCrypt. Enter. What do we see as the first hit? Raymond CC blog, easily create TrueCrypt encrypted container files with DrupAx. All right, let's do you know what? Let's go to SourceForge projects, TrueCrypt. Next one down.
Oh.
So what does SourceForge got to do with TrueCrypt? Yeah, well, guess what? SourceForge now basically picked up the TrueCrypt project. They didn't really pick it up. They did what? They just let you download it from them. SourceForge. It's interesting that SourceForge is owned by Microsoft. When TrueCrypt went down, they put up a little thing that said, hey, we recommend you move to BitLocker. We recommend you move to BitLocker, Microsoft. Microsoft picked up TrueCrypt. TrueCrypt is now hosted on SourceForge. Seems like some sort of relationship going on there, right? All right, not that that's part of this, but let's do this. TrueCrypt is here. Let's go to web related. Under web related, do you see the one that says, hang on a sec, Internet Explorer history, the very first one? What is this? Let me know what this is? Go ahead, what is this? Well, this is not a TrueCrypt container. It's not one. Obviously, right? Not a TrueCrypt container. It's exactly what this is not. Yeah. All right. What is file colon /////?
Well,
If you don't walk away with anything from this session, there are 4 nuggets you need to walk away with. This is one of them. I don't care if you got to write this down, take a picture of the screen. I don't care what you got to do. File colon //// is an indicator of a locally accessed file. Internet Explorer and Windows Explorer are on exactly the same framework. So when I'm inside of Windows Explorer, when I double click on a file, guess what goes into Internet Explorer? Sorry, when I'm in Windows Explorer and I double click a file, guess what gets generated in Internet Explorer? A history link. A history link for that file. A locally accessed history link for that file, which not only gives me the fact that it was accessed, who accessed it, when did they access it, and how many times have they accessed it based upon the internet history. I never accessed that file. Really? How many of you guys use Internet Explorer? You do? Use Internet Explorer? You have time to move on. All right. I use Edge, I use Firefox. I use Edge on my Surface Pro, but I use Firefox everywhere else. I'm a Firefox person. How many of you here use Chrome? And how many of you use Firefox? Okay, it's usually the world of either or. Those of you that don't use Internet Explorer, so not you, sir. Those of you that don't use Internet Explorer, how many of you go into Internet Explorer and you clear your history? I mean, you don't use it, so you clear it in Internet Explorer? No, you don't. And guess what? Neither do bad guys. Because why? Why would you clear history on something you don't use? This isn't history generated by the user. This is history generated by the system without the user's knowledge. So I always expect to see file colon //// on my drives, showing me what they access locally. You with me on this? Where's this coming from? RAM. So I haven't even got to the hard drive yet. I usually process my memory separately from my hard drive. Yes, I'll put it in there, but how long will it take me to process a 32 gigabyte memory image versus how long is it going to take me to process a terabyte hard drive? So I can get in there and start doing this. How long have we spent in here so far? 20 minutes? And I already know TrueCrypt was running, and that the potential container is not the TrueCrypt container, not a container, right? Okay, so now I know some of the things I'm going to start looking for when I look for the hard drive, when I see the hard drive come out on my investigation. Right, that's a head start I'm getting. All right, so let's take this. Let's go ahead and clear filters real quick. Let's take a look at Google searches. If you look at Google searches, one of the Google searches you'll see that's right there, Tara just had her mouse on it, that one right there, it looks like TrueCrypt, but it's not. You'll have to excuse me if you'll see this was 1:49 in the morning when I planted this evidence. Maybe a couple of beers into it, I'm not sure. I'm pretty sure, but I'm not sure. I misspelled TrueCrypt. But What's the time and date on this? Let's go ahead and go with it. 3/9/2019. And what's the time?
149.31.
149.31. All right. So TrueCrypt is being used on here at 149.31. They went and did a Google search for it. Let's take a look at something like that Internet Explorer file : / that was down there. Let's just go ahead and type in TrueCrypt again. Now that I know this is the search, type in TrueCrypt one more time. Let's filter for that, the real TrueCrypt. Will the real TrueCrypt please stand up? All right. Let's go back into operating system here. Let's take a look at the link file. What is the link file and what does the link file show us? Are link files created when you double click on a file and activate it?
Yes.
Yeah? Okay, I'll go with that. In the MRU, right? Most recently used, recent folder, all that stuff, okay? Does it have to be in RAM before it goes to the hard drive? Yes, it does. Why? Because the CPU can't talk to the hard drive. CPU can only talk to RAM. RAM talks to hard drive. Okay? So take a look at this. When was this ran? Target file created? This TrueCrypt setup, when was it created? 3/9/2019 at
150.49.
150.49. Okay, we're looking at what? A minute later? Makes sense. It downloads, then it runs. Okay, let's take a look at Windows timeline activity. What's that about? Go to the Windows timeline activity. What do we have here? What's Windows timeline? Anybody know?
Windows 10.
It's a Windows 10 artifact. Windows 10 1803 and higher artifact. Go ahead and click on your keyboards right now. Click Windows Tab. Everybody on your keyboard, click Windows Tab. You see this? This computer's been active since the first day of the conference. If I cycle down on the right-hand side, if I just hit the down arrow, it will move down for me and show me the rest of what's happened this week. Well, we have some PowerPoints there. We got some yesterday PowerPoints. We have a Google Chrome hit on June 1st. You get the idea, right? This is a timeline history of what this user's been doing on this computer for the last 7 days. If they logged in with a Windows Live account, this is 30 days. Okay? This is a Windows artifact that we recover in AXIOM from computers. But what's more important is not only do we pick it up from computers, can you kill that? Hit escape. Open back up. Where are we pulling this from? Windows Timeline and RAM. Yes. Windows Timeline and RAM. It's written to a file on the hard drive, but before it goes there, where does it go? We don't care. That's the great thing about AXIOM. We don't care. Give us data, we'll parse it. Get it from anywhere. We were talking about drones earlier. Shoot a drone down. Do a chip off. Put it in a USB device. Collect it. Throw it into here. Guess what? We'll look at it. We don't care what tool you use to grab it. We don't care what kind of data it is. We're still going to look for it for all artifacts that meet our artifact categories. Okay? Windows Timeline is one of those, obviously. We have TrueCrypt 7.2. What is this? What is that? That's the installer. 7.2 is the version. That's the installer. Okay, so we have the installer running at 150.39. Okay, let's go to Windows Event Logs while we're here. Why not? We're here. Take a look at Windows Event Logs. What do we see in Windows Event Log for the first one? That's coming from System Restore. Okay, I'm going to move on. We'll look at the next one. This one's coming from the local system. What is this? Microsoft Windows Program Compatibility System. What is that? It's got something to do with TrueCrypt because we sorted the TrueCrypt, right? So this is only dealing with TrueCrypt right now. What is the Program Compatibility Assistant? It is the shim cache. Very good. Let's talk more about that in a way that people that don't understand what shim cache is can get it. Program Compatibility Assistant. Every time a program runs on a version of Windows, it has to get checked, is it compatible with this version of Windows? Which makes sense that they call it the Program Compatibility Assistant, right? It gets put into a file that it passed or didn't pass. The second time you run it, it checks the file. If it's passed, it moves on. If it hasn't passed, it checks it again to make sure it's not with the most recent version, and off it goes. Does this mean he ran TrueCrypt? Well, let's go down a little bit. Let's go cycle down and look at in the details card. Let's look at the bottom line. Stop right there. So take a look at the time here. what time did this? System time. 2019, 0309 at 150. 2019 at 1:50:39. This is when the program ran. This is when the Google search, so Google. What's this bottom one? The PCA. Do you think the PCA had to check it, the program compatibility assistant had to check it prior to actually running it? Yeah, how long did that check take? 1:50:39 to 1:50:49. This is when it ended and actually installed, was 1:50:49. Took 10 seconds to check it and install, right? That makes sense to you? All this is coming from where? You sure you want to leave that RAM behind? Are you sure? All right, let's keep going. Let's take a look back at, let's stop for a sec. Let's go up here. This time frame is starting to get pretty important to me. Go to the top of this details card. At the top of the details card, by this time, you see where it says created date and time? And there's this clock looking thing that Tara's pointing at right here? That is a relative time filter that AXIOM uses. A relative time filter, what is that? It locks in place that time, and it lets you filter so many minutes in front of, so many minutes in back of, or a combination of the two. I want to know what else this person was doing besides just running the program compatibility assistant, just besides running the program, because I might stumble across the actual file that the TrueCrypt container was, not a TrueCrypt container, right? I might be able to stumble across that file, or a file like it. Or I might want to find out something else that happened during that time frame to pinpoint the person in the chair. Because the bottom line is, as examiners, whether it's corporate or law enforcement, we want to put somebody in that chair, don't we? I can show you a profile that did it. That's the easy part. But I can't tell you who was sitting in the chair that typed on the keyboard. Unless I start getting things like, okay, did they log into their Gmail? Did they also do this? Did they also do that, right? So let's take a look. Hit that time filter, that relative time filter, and let's go with, 3 minutes. We'll do 6 minutes. 3 minutes on one side, 3 minutes on the other. If I wanted to, I could take that check mark out where it says set range, and then I could tell I want 3 minutes before and 0 minutes after. I can do 3 minutes before, 10 minutes after, but I'm just going to leave the check mark on and use 3 before and 3 after. Is everybody okay with that? Hit OK. It's going to produce the results in the timeline view. That's what this is telling you. I'm fine with that. This is the new timeline. It just came out with version 3. Very, very happy with this. How many of you guys use the SANS timeline model right now? Yeah? You're going to stop. There's the good timeline model. Don't get me wrong. We based ours somewhat loosely on theirs because it was a good one. And we added so many more time points. Think about it like this, and I'll make it quick because I'm short time. The Windows timeline, Windows times, specifically in our Windows timeline. How many times does a file have associated with it? Well, if I just talk about a standard file with map times, I've created access written, right? But if I look at a link file, I've created access written. I also have a target file created access written, now I have 6. How about a prefetch file? A prefetch file, I have created access written, but then I have the last 8 times that program was ran. That's a time as well, right? So now I have 11 times. All of those are all in the timeline. Every time that we have, that we can think of, that's important, even event log times, those are thrown into the timeline as well. You're going to find out that the timeline is going to be your new friend when using AXIOM to do examinations. So let's just, right now, there's a whole lot of information here. You'll see how this little gray piece of the scroll bar, we're only looking at 6 minutes, and look at all that other stuff that we could be seeing right here, right? So let's filter this down even further. At the top, you see timeline categories. Ever see timeline categories in the filter bar? Let's drop it down. I'm going to select some specific timeline categories because I know TrueCrypt is a program. So I'm going to talk more about that in my timeline. So I want to go to browser usage. I also want to go to file downloaded, check file downloaded. I'm also going to go down a little bit more. I'm going to choose file folder opening. Down a little bit more. Program execution. Let's pause before we hit go. If I had any chats going on with the chat application, if this was a chat application instead of TrueCrypt, you can't really chat and communicate with TrueCrypt, right? But if it was a chat application I was concerned with, or an email application I was concerned with, I would choose also user communication. We're going to rebuild the user communications in the timeline to show you, he said this, then he said that, then she said this, then she said that. All right? Hit OK here. All right, kind of makes it a little bit more usable because here's my gray line. I only have to look at this now. What's the first thing that happened? Well, if we click on it, it looks like we have some sort of Bing going on, but wait a minute. We're not specifically looking at TrueCrypt here, are we? We're in the timeline looking at a date and the browser usage. If I want to specifically put this down to TrueCrypt, what do I have to do? Stack another filter on here. Let's put TrueCrypt in the upper right-hand corner, stack a third filter. I'm doing a time. I'm also doing a specific timeline categories, and now I'm going to put a keyword in there of TrueCrypt. There you go. Oh, now it's getting even better. Here we go. What is this one? What's the first category now I'm interested in? And how long did it take me to filter all that information to get here? This is the download itself. HTTPS, source forge, projects, TrueCrypt files, TrueCrypt 7.2 exe, download. Where was it downloaded to? Well, I don't know yet by this one, but I know it's downloaded. Do you agree with that? And I have my date, which is the same date we have up here, close to it. Let's go to the next one. Looks like the same thing. Could be in two places in RAM because we carved it. If you'll see that it says recovery method carving. Everything in RAM is going to be carving because there's no structure to it. How about the next one? Okay, program files, TrueCrypt. What does this tell me? What does it tell me?
Right.
C program files tells me that it was ran for sure, but what else does it tell me? It was
Where was
installed.
it?
It was installed for sure. Matter of fact, it ran from the program files folder. How does stuff get in the program files folder? And when did it run? That's my 15049. Okay, so let's go to the next one. Program execution. This is the process list. This is coming from specifically volatility, right? Are we running that close? What time is it? How much time do I have? Are they finishing early?
13 minutes.
13 minutes. Okay, I'm good. Woo! Sorry, they just scared me. So if we take a look at this, it gives us the process ID, it gives us the process start date and time and the process end date and time, okay? This is the installer. How long did it take to install? That's what that is. Let's look at the next one, program execution. What's this one? Same thing, carved out differently. Let's look at the next one. I can keep doing this. What do we see here? Volume serial number. Guess what the volume serial number of my C drive is going to be? I mean, are we tracking the amount of information we're pulling out of RAM on just TrueCrypt alone? Let's keep going with this. Look at the next one. Keep going. Actually, go down to the one that says process list, please. We can do link files all day long. What is this one? TrueCrypt 7.2. That's still the installer. Go to the next program execution. 7.2 is the installer. Keep going to the next one. This is where it's carving out from different places. Keep going down to, well, wait. This one is pulling from PSX view, not PS list. It's telling me whether it's hidden or not hidden. It's hidden from view in the PS list. It is showing. It's showing in PS scan. The thread processes. It's not a multi-threaded application, so that's okay. It's showing in the session time. So there's some places where it's hidden. The more false I see, the more I'm looking at it. Look at the next one, please. And that's one we've already seen for the download. Process list. You guys get the idea with my timeline? I'm seeing everything I can about TrueCrypt. Now I've got to move on because I'm only at 13 minutes, but let's take a look back out at Artifact Explorer. So from timeline, I'm going to jump over to Artifact Explorer. I'm still filtered for TrueCrypt in here. That's fine. I want to go down to, is there email? I'm not seeing email. Do we have multiple filters running? Take out, get rid of the filter. Sorry, we're done looking at TrueCrypt for now. Clear filters on that and just go to email. The email I want to look at is Gmail fragments. So if you'll take a look at Gmail fragments, there's only 3 of them. On the bottom left-hand corner, we currently have all email, all 8 of them, tagged. I just want to look at Gmail fragments and show me 3. In the middle one, let's take a look at the middle one. And what do we see here from the top? It's carving it out of a JSON bubble because this is actually Gmail, as you'll see up here. jamie.tubbs@gmail.com, subject $124 Samsung 860 EVO. What is that? Micro Center sent me an advertisement in my email account. I checked my email while I was waiting for something to finish. Oops, you got me from planting evidence, right? Okay. Who was sitting at the table? Turns out I am. All right, so I'm the bad guy. Well, let's keep going with this because I can look at the time on this as well. What's the time say? 2000, oh, go back up a little bit, sorry. Right there in the JSON bubble. March 8, 2019. Is that before this? At 6:48 a.m.? This is way up here, 6:48, 3:8, not 3:9, 3:8. Okay, so it doesn't really put me at the table at that time. That was the laptop. I was the last one to use it. It was one.
That's an email, Dave. Not a big extra.
that is an email date that it was sent to and from, right? But it shows I'm in the chair, right, at that time. So let's keep going down a little bit more. It says, right there, it says thread, building a house. Bob, I'm building a house. I need your help. Can you assist? Sent from my iPad. Okay, now I know I'm looking for a what? An iPad, right? If we didn't have that, I'm looking for one. It happens to be this one, but okay. We'll call it good. Can you assist? Keep going down here. Who is actually receiving that email? It looks like Bob, but Bob who? Hi, Bob. I'm so glad you decided to try out Gmail. Here's a few tips on running fast, blah, 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 blah. Right? We just passed it, I think. Bob what? We'll see it in a few minutes.
Is it there? Keep on.
I don't see it right there. It's somewhere in here. Might be up farther. I'm not seeing it. We'll take another look at it in a minute. It's Bob Vila. Because I was building a house and I needed Bob Vila's help. We saw the file // before, right? We saw one of those options for TrueCrypt 7.2, and I told you what that was. That's a locally accessed files. So why don't we just use that as our search term? Search for file // in that upper right-hand corner search bar. File // Hit enter. What are these? These are the files that were accessed really recently because they're still in RAM, right? So what do I have? Class files, D, drive on mobile laptop. It was one of these laptops. Class files, zip torrent. We have some torrent things with virus share. We have that not a TrueCrypt container. Now we know where it's located. C, user, student, desktop, not a TrueCrypt container. We also have, if you look about, it's got a little blue marker next to it. If you look at it, there's hashcat. And there's also one hashcat again. And there's also one in here, if you keep looking, called mimikatz. Anybody know what those are? What are they? Password cracking utilities? Am I concerned that that's on my network or on his system? I'm good. It's on my system, actually. But yeah, no, you would be, right? So all of these are things I'm just trying to show you, like, think about the amount of data we've pulled so far. All right, let's take another look. Have I looked at Google searches? Who ran it? Do we know who ran this yet? What user? How do we find that student?
It says right there.
Right there in user. That's the link file. That's the file // What SID belongs to student? Well, let's go look. Clear filters. We can do this one of two ways. We can right now go down to operating system artifacts. Is there any users in there? That doesn't really work, does it? How about we do this? Let's search for TrueCrypt again. Because I'm not worried about it. It only takes 10, 15 seconds to run this, so I'm not worried about how long it takes. Now when I'm in TrueCrypt, one of the things I want to look at is I want to take a look at the memory. Open up memory. This is the volatility module. And I want to look at the one that says get SIDs. In the one that says get SIDs, 3 from the bottom, this is TrueCrypt, right? Who's the only user profile mentioned here? 1003? 513 is a group. 1003 is the only SID I see here. Agreed? So we already know student was a part of it. Is 1003 student? Yes, it is. Now, I'm going to have to verify that and validate that when I get where? Into the computer. But right now, this is where I'm at. Okay? So let's do this. Let's take a look at, there's a thing called, get out of, TrueCrypt. Close our TrueCrypt filter. And when we go up here to identifiers, you see the identifiers up there? Identifiers is something that AXIOM uses. Keep me straight on time, please. Identifiers is something that AXIOM uses to add a email address to a person, a chat name to a person. You name it, anything that identifies a user, a person, we track this in the identifiers column. What do I see here with a pink, magenta, whatever? Mike and I argue about that all the time. What are we talking about there? What is Bob Vila at Gmail? It's a email address, right? But in this case, AXIOM picked it up because they're the owner of a OneDrive file. So he's sharing something, Bob Vila is sharing something in OneDrive. I don't know what that is yet, but he's the owner of it. And guess what his internet user ID is for OneDrive, Office 365? C1FDBC, that's the owner ID, or the internet user ID. If I want to send off a warrant to Microsoft to find out how Bob Beal is investigating in my case, what Microsoft stuff he's got going on, guess what I can do? Send him the internet user ID. They'll tell me everything I want about him. Okay? So same thing for Bob Vila, same thing there. Let's take a look at those OneDrive files we just saw that Bob Vila was the owner of. If we go down to cloud storage on the left-hand side, in cloud storage, guess what we see here? Hashcat and Mimikat's inside of that, right? And if you look over on the right-hand side, we see some more information here. We see that, again, that belongs to Bob Vila. There's his owner ID, and the last time that file was modified was 3/9/2019 at 3:13. I worked a little late that night.
5 minutes.
Or a little early. Yeah, 5 minutes left? Perfect. All right, so I even have the file size. Basically, the only thing I'm missing here is the hash, right? Got everything else I want about this file. Okay? Let's take a look at let's go back to Memorex. Take me back to the PowerPoint, please. Go to slide number 32, I think it is. Just because I'm running a little bit short on time, I'm going to take it back to Memorex and we're going to skip through it pretty quick. Joey, this is what you were talking about, right? When I recover pictures from RAM, I see partial pictures because it grabs the header of the picture, but it doesn't know where the rest of the picture is because it's spread out throughout RAM in the pages. What if I could put this, again, these memory images for Paint or for Word or for PowerPoint back together prior to carving memory? Next slide. What if I could do that? We have something called, on our website, for free, go get, it's under free tools. What if I could go grab the magnet process capture? It checks the memory space, interrogates the memory manager, puts the executables back in their order, and downloads them into files. If I think there's malware being used on the system, I can also zip the output. Output each process to a password-protected zip file, because I don't want to take out potentially live malware from RAM and put it on my system, not protect it, right? So that's one way we've added. But imagine if I collect all of these. This is what RAM looks like at the top. Memory just kind of spread out everywhere. Everybody okay with that? When I carve it, that's how I carve it. If I put it back together like this, it'll put back together 1, 2, 3, 4, 5, 6, 7, 8. That's the TrueCrypt container. Here's Chrome. 1, 2, 3, 4, 5, 6, 7, 8. And when I carve out pictures, this is an example of Chrome that's been put back together. This is Google Earth in Chrome. And do I have any gray images here? Nope. And these are map images, so you know they're big. It put it all back together before I carved it. So I'm seeing full-on images here. And how many images did I recover? More? 1,822. Just from Chrome. Everybody okay with this? Magnet process capture, it's free. Go get it. Run RAM first, collect RAM first, then collect process capture. All right, so this is a piece of memory. Our TrueCrypt started. Our TrueCrypt started and its process ID was 14352. The parent process ID, meaning the process that spawned this process, was 7820. What process was that? Let's go up to 7820, Explorer.exe. What is Explorer.exe? Everybody go Windows E at the same time. Windows E.
Windows.
That is Windows Explorer. Yep. Some people call it File Explorer, right? Okay, same thing. What started File Explorer or Windows Explorer? Well, 6560 is the parent ID, so we go to 6560. What's user init? This is key. Yeah, it stands for user initiated. As part of the logon process, as you'll see in a few minutes when we track that backwards, as part of the logon process, an application called user init starts, waiting for you to do something, and as you do something, it will kick off that something. When you hit Windows E on the keyboard, that's a shortcut. That shortcut is being activated by user init.exe. Guess how I got Windows Explorer open? I clicked on Windows E. Windows E kicked off user init. User init kicked off the file explorer. I double clicked from there on TrueCrypt and it launched. Let's go backwards from that. What was user init launched by? 920. 920, follow the green arrow, goes up to win logon. Remember I told you user init starts when the user logs on. What does win logon start by? 808. 808 starts by the launcher. Launcher is part of the login process. You see how I'm doing this? Could there ever be a time when I can't follow the chain? Yes. Don't get upset about that. Imagine this. If I start a command prompt right now, and I go to the command prompt and I type in calc.exe, will it launch calculator? Yes. And it will show me that calculator was launched from the parent process ID that is the command prompt. If I close the command prompt and it's no longer there, I don't know what the parent process ID was because the command prompt's no longer running. You follow what I'm saying? There's a gap. It's normal. You won't always be able to track it. So in these I can. We already saw the program compatibility assistant. What about this IP address for network info? Now it's getting really close. Network info. Here I have my 172.217.14.69. 443. What's 443? It's a secure connection to the internet, right? Yeah. All right, so let's look. Who is this? I go out to centralops.net and I type in centralops.net as my who is, right? I type in who this is and what do I come back with? That makes sense because what did we see in there? Gmail, right? I was on my Gmail account, unfortunately. Speaking of Bob Vila, all right? Well, actually not Bob Vila, but Bob Vila, because Bob Vila was taken up in Gmail, and Bob Vila was taken up in Gmail. So it was Bob Vila. All right. Connections. If I went to that Bob Vila's identifier and I clicked on the internet user ID here, it would tack out everything that's associated with that. In this case, that is associated with the Bob Vila at Gmail, which is also associated with OneDrive, which also has Hashcat associated with it, and Mimikatz. You see how connections is working? And this is coming from where? All coming from RAM. Nothing from a hard drive, nothing from anywhere else other than RAM. I think I nailed 60 minutes right on, or 50 minutes right on the money. What questions do you have? Now, let me ask you one final question before you walk out of here. Are you going to change the way you handle RAM from now on? I hope so. Some of you don't get RAM. I get it. And if you don't get RAM, you can't investigate RAM. You're not the line investigator who would be the one to turn off the computer and collect it, right? And I get that. But then it becomes important for you to teach those guys the importance of collecting RAM. If you are the ones that are able to collect RAM, stick it into AXIOM. Look at all that stuff you get that you wouldn't have gotten otherwise. And a head start on getting your case going. But do you think if they could have got a head start, they would have? What if this was a terrorist case? And you want a head start? Even 5 minutes, even 10 minutes, what would that do for you? Sometimes, yeah, I'm gone on the weekend, I don't really care. I'll see it on Monday. Not for terrorist case, but for just my normal cases, right? I'll see it on Monday, I'm not that worried about it. But what if? What if it is that one case, the Boston bombing? And I can get ahead of that person by 5 more minutes or 10 more minutes to see they emailed so-and-so. We didn't identify that person as a subject yet. Let me go to that person's house. And I beat them back to that person's house. What are the chances? I don't know. And nobody does. And if I can give you a head start, I'm gonna. RAM, in my opinion, is the way to do it. Because the case is going to take as long as it takes the process. And we all know sometimes by watching the case, it's going to take a while. All right. Thanks for coming. It's my random talk.